All right, so like I said earlier, this is our last section for chapter 5. And at the beginning, I don't know if you have your book open, you don't have to, but if you do, there's a picture, and I just happen to have that picture right here. Oops. It's pretty big. It's exciting picture, isn't it? It's in the book. It's in the book. Let me get it to fit the space here. I should have done that earlier. That's all right. Let's go to about like this. All right. So it's not that exciting of a picture. I did not take this picture. Well, actually, I did. I took a picture of it with my phone from the book. All right. So, but this is a picture in the book. You see this all the time. In fact, do you know the little, as you go out to the modulars, right? You go out those end doors and you make a left to the modulars. There's that kind of like brick kind of pathway. It's not like a regular sidewalk. You know what I'm talking about? And it kind of cuts through a little bit. Well, they made that is because all the students that would walk out there would cut through it, and they made this path, excuse me, through the grass, and it just looked kind of tacky. And so I saw Mr. Pusey out there. This was several years back, but he paved it all, and so he made like a nice path right here, like a real path. So that wasn't always there. It was there because everybody cut through. Now, the whole purpose of this is because these kids right here, I don't know, maybe they started right here. They're walking this way, and they wanted to go down this sidewalk. So instead of going all the way to the end and coming back again, what'd they do? They made a little shortcut, didn't they? Right through there. Why did they do that? They just like the view here better, or what? Because why would you want to what? Walk all the way around. So tell me about that. Let's talk geometry. Walk all the way around. So from here to here would be what compared to this? No, the distance. Listen, don't just yell things out, okay? Think first before you say something, okay? So if you're walking this way, why in the world would you cut through instead of going on the sidewalk from here to here? The distance is shorter, exactly right, okay? Now watch, the distance is shorter. If you wanted to make like an imaginary triangle, right, make this one of the sides, this one of the sides, and this one of the sides. What this lesson is basically about is this, is that if I add up these two sides of the triangle, that's going to be what in comparison to that third side right there? As far as the distance is concerned. Is it going to be, well, we don't know an exact number. It all depends on the triangle, depends on what angle they use to cut off. Okay, but these two sides right here, this side right here, and this side right here, okay, what about the distance compared to this? These two sides would be what? Well, no, not exact numbers. It's just longer, okay? I'm not trying to get too specific here. It's just a greater distance, isn't it? Okay, it's a longer distance. That's why Sam said, why would you want to walk all the way to here and here when you can just cut right through? Do you agree? All right. So that's basically what we're talking about today. All right. And the title of the lesson is More Inequalities. I'll tell you what, let's just get rid of this picture. We already saw it. And let me zoom up a little closer. There we go. And we'll keep it right there. All right. So that's basically, thank you. So that's basically kind of what we're doing. It's the gist of what we're doing today. We're going to get a little bit more specific about it, but that's basically what we're doing. All right, so let me see. Let's just draw basically what we were doing. So let's say the sidewalk goes to here, and it doesn't. I'm going to draw it as a right triangle. It doesn't have to be, but a lot of times it looked like it was a college campus or something. Usually the sidewalks are perpendicular to each other. All right, so if you wanted to go from point A to point B, let's do that. If you wanted to go from point A to point B, what's the shortest way? And you've probably heard this before. Yeah, the shortest distance between 2 points is a straight line. Exactly, all right? So this is one line. Well, that's a straight line, isn't it? But you got two lines here, don't you? All right? So if I just wanted to go from here to here, that would be the shortest distance. So let's put a C here. I think that's how So let's write this. By the way, I don't think we did this in the first inequality lesson. When we talk about inequalities, so if I said like 3, if I said to compare 3 and 4, 3 is what compared to 4? It's less than, okay? Do you remember the less than symbol? Okay, did we do this the other day? Okay, it's this. That would be the less than symbol. Okay, and a lot of people learned it. Yeah, the alligator eats the bigger number and all this kind of thing. All right, look, we're in high school now, so I'm not going to go through the little kids thing. If that helped you when you were in middle school, that the alligator eats the bigger number, then that's perfectly fine. All right, I want to show you. Where this less than thing comes from. Now, what if I did this? What is that? Equal. That's an equal sign. Okay, now watch this. Is I take this side and I bring it down here, and I take this side and I bring it there, what does it become? So I took that equal sign and I made the distance between here and here what? Less. I made it less, didn't I? You see that? Right? The distance between this part and this part, I just made it smaller. So this little part right here means less than. This part right here means what? Greater than. That's right. Do you see that? That's basically where they got it. So what's a greater than symbol look like? It looks like this. Why? Because this right here is greater than this. You with me? Yeah. Now, you could read it right to left. Normally, we go left to right. So 3 is what? How would I say this? 3 is less than 4. Or I could read it from right to left. So I could say that 4 is what? Greater than 3. Everybody see that? We're not going to do a whole lot with it right now, but there's another chapter. I can't remember what chapter it is. It could be the next one. I don't even know. I haven't even looked that far ahead. But there's going to be a thing where we do a lot of this stuff. Okay, this is just a little tiny introduction to it, but we will do a whole bunch of this stuff a little bit later on. But you could read it left to right or right to left. You could say that this is 4 is greater than 3, or you could say that 3 is less than 4. Everybody understand that? And it means the same thing. I mean, both of them are true statements. Would you agree? That 3 is less than 4 and 4 is greater than 3? Sure. Okay, now let's take a look at this. With that said, the whole reason I went through that is because of this. If I took AC, now what if I just put AC and I didn't put anything over top of it? What does that mean? We've talked about this a lot. Doesn't just mean line segment. It means the what? The distance, the length of, okay? It means the length of AC. Everybody with me? I know it seems like a subtle difference, but it doesn't just mean the line segment. It means the length of the line segment, the distance of the line segment. All right? So that represents a number, basically. Would you agree? Because that's how we measure distances. We put numbers in there. So I could say that AC plus the length of BC is what compared to, I'll put a little blank right there, to AB. So AC plus BC must be what? Greater than AB. Would you agree with that? Yes. That works with any two sides. I could say this. I could say that AB, the length of AB, plus the length of BC. Do you see this one? AB plus BC must be what? Greater than AC. Would you agree? Yeah. All right. So it doesn't matter. Let's do one more since we're going there. So what do? We went this one plus this one is greater than this. Then we went AB plus BC. So now I could go what? AB plus AC. Couldn't I? Yeah. So AB plus AC must be what? Greater than BC. That's basically what we're talking about. All right? So any two sides. If I add up any two sides of a triangle, it doesn't have to be, this looks like a right triangle. It doesn't have to be a right triangle. It could be any type of triangle. It could be acute, it could be obtuse, or it could be right. Any type of triangle, if I add two of the sides, it's always going to be bigger than the third side. Everybody understand me on that? Yeah. Okay. If you add two sides and it's less than the third side, when you add those two sides up, it's not a triangle. Okay? Does it make sense? Yeah. All right. So, with that said, let's move on. This comes to our first theorem, and it's called the triangle inequality theorem. And it basically says what we just finished going over. So it's called the triangle inequality theorem. Let's just write it down. I wasn't going to write it, but let's do this one. There's a couple other ones we're going to do that I may not write down just because it's a lot of words, and I just don't want to take the time to do it. But this one's not too bad. It says the sum of the lengths of any two sides, the sum. Guys, let's stop, okay? I just feel like I'm in middle school with all this giggling going on, okay? It needs to stop. The sum of the lengths of any two sides, okay? It doesn't matter if they're the longer sides, the shorter sides, or anything. Okay, any two sides of a triangle, is greater than the length of the third side. The length of the third side. I'll just do that. I'm reading it off to you. The sum of the lengths of any sides of a triangle, or any two sides, let's put 2 in there, okay? The sum of the lengths of any two sides of a triangle is greater than the length of the third side. That's basically what we just finished saying. You can take any two sides of a triangle. If I add them up, it's always going to be bigger than that third side. All right, we just kind of talked about it right here. We demonstrated it, but this is what the actual theorem says. And that's pretty important because we're going to do things a little bit later that have to do with this theorem right there. All right? So let me do this. What if I had this? Now, I'm not like measuring these out precisely or anything. Probably could have made it a little bit better. But let's say this was 9, let's say this was 6, and let's say this was 5. They're going to ask you questions like this. They're going to give you 3 sides, and they're going to say, can you form a triangle with these 3 sides? I can't just take any 3 excuse me. I can't just take any 3 random numbers and expect to be able to make a triangle out of those 3 numbers, okay, those 3 lengths. Okay, it's got to be something specific. So can you make a triangle with these lengths? Well, let's use this triangle inequality theorem. So it says the lengths of any two sides have got to be bigger or greater than the third side. So what if I take 6 and 9? What's 6 plus 9? 15. Is that bigger than 5? Yeah, so far so good. What about 5 and 9? That's what? That's 14. Is 14 bigger than 6? Yeah. What are my other two sides? 6 and 5. So let's take 6 and 5, add those up. What's that? 11. Is 11 bigger than 9? Yes. Okay, so I can make a triangle, okay, with those 3 lengths. Really, to tell you the truth, the easiest way to do it is just take the 2 smaller ones, because you know if I take the biggest side and add it to something else, it's got to be bigger than the third side, right? That's just instinct. But let's take the 2 smaller ones, okay, and that's always the one that we want to try. Take the 2 smaller ones, 6 and 5, add them up. Does the sum, when I add them up, is it bigger than that third side? Yes, it is. So is this a triangle? Yes, this is a triangle. Okay.
Does it always have to be labeled like the letters or anything?
Nah, they might just give you like this. In fact, they might not even put a triangle in there. And I'll tell you right now that they're going to give you some problems where you're not even going to see a triangle. They're just going to give you numbers. So they'll give you like 5. I think they might put dashes. I'm not really sure. Could put commas in between. I don't know. So if you have 5, 6, and 9. So here's the question they could ask. They say, here's 3 lengths, or here's 3 distances. Can you form a triangle out of these 3 distances? So what do? Add the 2 smaller ones up, and it has to be bigger than the third side. If that's true, then you can make a triangle out of it. And that's it. Now, we don't know what kind of triangle just yet. Okay, later on in another chapter, we'll learn that. What kind of triangle this actually is. Is it acute? Is it right? Is it obtuse? But right now, I just want to figure out, does this thing make up a triangle at all? All right, because there are some sums, S-O-M-E, some sums, right? Things that are added together that don't. So what if I had this? What if, I'm not even going to draw the triangle. What if I had 2, 6, and I'm sticking with 9, I guess. What if I had this? Does this make a triangle?
No. 2 plus 6 is 8.
You're not thinking. You just shouted something out. It does what? Not make a triangle. Why? Because I take the 2 smaller sides, 2 and 6. 2 and 6 adds up to what?
8.
Is 8 bigger than 9? No. So I cannot make a triangle out of sides 2, 6, and 9. Does that make sense?
Yeah.
It has to be bigger. Like, what's those people?
What does this say?
3.
It doesn't say equal. What's it say? Say it. Greater. Right. It says greater than. All right. So it can't be equal. All right. So for instance, I'll just show you. Give you a good example. What if you had this? It would be. No, he's right. He's absolutely right. Because that's, if I could grab this thing, come on, there it is. Okay. I copied and pasted those, so those are exactly the same. I'm going to just make it a different color just so they stand out a little bit. Okay. So here's two lengths, okay, of a triangle. Now watch this. If I put them together, and let's do this. I'm going to try to make that exactly the same length. Let's put that as a different color as well. Okay? Now look at this. Can I take these 2 sides, or these 3 sides, I should say, can I take these 3 sides and form a triangle out of them? Possibly?
Oh, no, yes.
Remember, this and this are exactly the same.
Yeah.
Okay? Because look, if I put this here and I rotated it like this, like that, okay? And I could have just rotated just a little bit. Let's see if does it rotate? I think there's a way to anchor it at that point, and I just don't know. Let's make it really like a really skinny angle. And what if I did this? Come on. There we go. Watch. And let's take this and move it to about right there. Okay. It's not going to make... I didn't do this very well. Let's forget the angles. Let's do this. Okay. So watch this. If I put this right here, and then I put this... I should do this on Geogebra, shouldn't I? Come on. Grab that thing. Why can't I grab it? It's so weird. I grabbed the other one. Come on. I cannot grab it. All right. So watch. Let's just, I don't know why I'm not able. There it goes. Now, why can I do it now? Shh. Guys, it's not that funny. It's really not. Okay. So come on. Be a little bit more serious. Okay. If something's funny and you laugh at it, I'm fine with that. Okay. I'm not a complete party pooper, but you guys go nuts over this. Okay. This little giggling stuff. This is bad as people like yelling out in my class. Just can't stand all that giggling. So if I put this right next to this, now watch my hands right here, okay? If I put it like this, as soon as I start making an angle out of it, what happens? I got a gap, don't I? All right? So there's no way, and I can't really show it here that well, and I should have practiced this on Geogebra, but I didn't. Girls, knock it off. It's really getting old. So there's no way I can make a triangle if this side and this side are exactly the same, okay? Now, if this side, it's even easier to see if this side was shorter. So watch. If this side was shorter, there's absolutely no way I could do that, is there? All right, because if I can't do it with my hands because I can't make my hands shorter, okay? But if one was shorter than the other one, right, they would be like this. And I go like that, right? And there's even a bigger gap in between them. So there's no way I can make a triangle if they don't add up to be bigger than the third side. Okay, these two sides have to add up to be bigger than that blue one right there. I know I didn't demonstrate that super well, but you get the idea. All right, let's move on. Okay, this one I am going to use Geogebra, but I'm going to write it down first, and then we're going to go to Geogebra and show it. It's called the Hinge Theorem. A hinge. I'm not going to write this down because it's very lengthy, but it is in the book, okay? So you probably want to write it in your notes at some point. I'm just going to read it to you. Now, when I read it to you, you're going to be completely confused, but we're going to take it and show you on Geogebra how this thing works out. We're going to compare two triangles to each other this time. We're not just looking at one triangle. We're not just looking at the sides of one triangle. We're looking at the sides of one triangle compared to the sides of another triangle, okay? In fact, I tell you what, I can write it down on here because I do have a little picture I drew for this, and I'll kind of demonstrate it, but I think Geogebra will demonstrate it much better, but I'll do it this way first. Let me just read the theorem, okay? It says if two sides of one triangle, so we're talking about two triangles, okay? If two sides of one triangle are congruent to two sides of another triangle. So I got two triangles. Two sides on one are equal to two sides of the other, okay? And the included angle. Now, what did we learn about two sides and an included angle? If the two angles were equal, then the triangles were what? Congruent to each other, right? But these included angles are not equal to each other now. Start again. If two sides, and it's in the book if you want to look, if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first one is larger than the included angle of the second one, what do we have? I got two triangles. I got a side equal to a side here. I got another side equal to another side here. But the angle between them, the angle on this triangle is going to be bigger than the angle of this triangle. You follow what I'm doing right now? You'll see it in a picture. I'll draw the picture in a second. It says then the third side of the first triangle is going to be longer or greater than the third side of the second triangle. That was a lot of words, okay? But let's draw a picture to describe it. So I've got two sides of one triangle equaling two sides of another triangle. So let's do that. If I could get this thing to work. So that's that one. I'm going to copy and paste it and put it over there. Okay? With me so far? And then I got another side that's equal. So we'll say that this side right here, and let's copy and paste that, is equal to this. But I'm going to do something with this one. I'm going to rotate it a little bit. Let's rotate it like that. Did I change the length of it at all? No, I just changed what direction it was going. Agreed? So let's take... And then what I'm going to do, so we'll put some numbers in here. We'll put some tick marks in here in a second. But I'm going to finish up this triangle, and then I'm going to finish up this triangle right here. Oops. Yeah, it's close enough. Now, let's try it again. Right. Still did the same thing. That's okay. It's good enough. So what did we say? We started off with this one was equal to this one. Agreed? And then I said that this was equal to this because I copied and pasted. So you know they're equal to each other. Now, what does the theorem say? What does the Hinge theorem say? It says that the angle, the included angle of the first triangle is going to be bigger than the included angle of the second triangle. So this is bigger, so I'm going to put two arcs on this one. This is smaller, so guess what? I'm just going to put one little arc on this one. That just shows that this one is different than this, okay? This one is bigger than this. So what does the Hinge theorem tell us then? This is all the stuff that's given. You're given that two sides are equal, but the included angle of this one is bigger than the included angle of this one. So Braden, what's true about this red line right here compared to this one? That's right. Then the side opposite the bigger angle is going to be bigger than the side opposite the smaller angle. You with me on that?
Yeah.
All right, so let's put like a big 3 right there and then a little tiny 3 right there. It's not really the best way to do it, but you get the idea, right? So the side with the bigger tick marks is bigger than the side with the smaller tick marks. They're not equal to each other just because they have 3. I just did that. Does that make sense on the Hinge theorem? So if you have two sides that are equal and an included angle that are not equal, right? We just finished doing a chapter with side angle side. Remember that? So I think I've taught out of a book where they call this the side angle side inequality theorem. All right, the side angle side inequality theorem. But this book calls it the Hinge Theorem. I've seen that as well. It's not uncommon. It's not just this book that uses this. All right, so it's a very common word. And that's the hinge. All right, let's show you. Oops. Where is this? There we go. I got to change. There we go. Now I've got Geogebra up. So now bear with me because we're going to show you. I've done this once, so let's see if I can do it again. So watch this. I have a length. Yeah, there we go. That's better. There to there. All right. And what I can do, I don't know why that came up. What I can do with this, I can choose this and actually make a certain length out of it. Okay, we can make it whatever we want. I think down here, right there, segment with given length. Oh, no, I know. Hold on, give me a second. Again, let's just delete that thing. This is actually pretty cool if I can remember how to do it. Let's clear all. Let's try this one more time. Don't save. All right, let's try this again. There's a thing down here. I know you can't see it on the screen. On YouTube, you should be able to see it. It says segment with given length. So if I click a point and then I put a length in there. Let's see. Let's use 8. This is what I used in a picture. So that's got a measurement of 8. And then I'm going to do another one. Let's click here and let's make this one 5. Actually, let's not do that. Let's put it right here. And then we can make that 5. Okay? Now, what's kind of cool about this, I can grab this. See that? I can move this around like that. All right? So let's do that one more time. And I can actually write in what the lengths are. Got to remember where to do that. That's somewhere in here. There it is. Click that. Oops. Yep, click that. That's 8, and then that's 5, just like we made it. Everybody good with that? All right, let's do it again. See if I can do this a little faster this time. I got to come down here to segment with given length. Click on that. We'll call that 8 again. Hit OK. Then I'll start here, and I'm going to call this, what did I call that one? 5. Hit OK. And, oops, got to get out of that. And let's do that right there. All right, now, this is kind of cool. This is where Geogebra really helps. So I'm going to make this a triangle, connect that to that, and then I'm going to connect that to that. And then, oops, and then what I'm going to do is I'm going to find what this angle is. So if I click here and here, that tells me what that angle is right there. I'm going to move it so you can see it. Everybody with me? All right, let's do the same thing here. So I'm going to go to angle. And then I'm going to click right there and click right here, and it's going to give me that angle. Now, what's kind of cool about this is, look, I can move this around. Did I change the 8 and the 5? The 8 and the 5 stays exactly the same, okay? But the angle in between changes, doesn't it? So what do you think is true about the third side? In this case, it's AC. As this angle gets smaller, what happens to that side right there? That gets smaller. As this angle gets smaller or bigger, so if this one is bigger than this one, guess what's true about the third side, DF? It's going to be bigger, isn't it? All right. If I wanted to, which I do, I want to, let's find actually what the length of, and that's what's nice about this program. It tells you exactly what the length of the third side is. So watch, as this angle gets smaller, let me put that right there. As this angle right here gets smaller, then that side gets smaller. Do you see it, that third side? As it gets bigger, right? So what's this one? 129.8. Let's take this past 129.8. And what's my length? It's 11.8, isn't it? So what if I take this past 129? So let's go past 130 right there. Look what happens now to that third side. It got bigger, didn't it? Okay, if I kept it exactly the same, I don't know if I could get it to be right on there or not. That's pretty close. All right. Now they round. All right. So it's rounded to 1 decimal place. So it's basically the same angle and it's basically the same side right there. Everybody see that? That's what the hinge theorem is. You understand why they call it the hinge? Where is the hinge on this one? It's at B. And then where is the hinge on this one? It's at E. So those two stay the same. The angle changes, so the third side changes. That's what the hinge theorem. Now, there's also a converse of the hinge theorem. So I'm not going to draw it out because it takes too long. Okay, but what if they told you not the angle, but what if they told you this third side was bigger, okay, than the third side over here? What must be true about the angle then? Then the angle's got to be bigger. Do you see the converse of it? It's basically the same thing, okay, except in reverse. So this one, the converse of the hinge theorem says, if the third side is bigger than this third side, then that must mean that that included angle has got to be bigger than that included angle. And that works, doesn't it? You see that? Okay. So that's kind of cool, don't you think? It's something I can't do just with my regular program that I use. But let's go back to the regular program. And I believe, well, there's some examples, but we've kind of run out of time. So I think the examples are pretty straightforward for you. So yeah, I'm just gonna give you what your homework is. Oh, I didn't even write it down. It's on your thing, isn't it? So it's section 5.5, page 239. 238 and 239, and it's just 13 to 16. That's it? Okay, I thought there was more. All right, so that's it. And I think tomorrow, am I correct? Tomorrow I do more than 25. What is that? Okay, so I got 4 more to do tomorrow, and we're just going to do that in class and just add it to this. So there's not going to be an A and a B. All right, we'll just add it to this and make one homework assignment. Everybody good? Yep. Read the examples. I think they're fairly clear. Okay, it's not really difficult. I just ran out of time to go over those, so there we go.